Hey everybody, welcome to lesson 11 activity. I'm hoping to keep this one short and sweet since it's a 3 activity week for you all and knock it out and learn a lot while we're at it. The objective of this activity is simply to just draw a checkerboard. We're going to be using the fill rect method. That's the only graphics method we're going to be using, and we're going to be using it to draw these red and black squares to create a checkerboard. Excuse me. We're going to be using a nested loop to do that. As I showed you with the grid of stars that I drew in the lecture, nested for loops, are really good at drawing grids of things. And so all we have to do is figure out the math for what color we're going to do it and how to move the squares over as our loop continues. So the math is actually kind of cool. I never thought about this, but red squares in the checkerboard occur when the row number and column number are both even or both odd, and squares are black when one is even and one is odd. And so the important thing to know is that our row numbers and column numbers start at 0. So this red square here in the upper left-hand corner is at row 0, column 0. Likewise, the one to its immediate right, the black one, is at row 0, column 1. And the one below it is at row 1, column 0. That's kind of how we go and count those. So let's go over to the code, because we're given some important information to start with. I imported checkerboard.java already. This is how it comes in. Again, since this is a graphics one, you're going to be doing all your work in the paint component method that draws the checkerboard, as we see from our Java doc right there. So notice we get the width and the height of the screen as always, and actually the box width and box height have already been calculated for you. So that's going to be the width in pixels of the box and the height. So all you have to do is figure out the X and Y position of the box. And by moving that and drawing the box over and over again, you are going to fill up the screen and create a checkerboard. And our checkerboard is going to be 8 by 8. That's the number of rows and the number of columns there and those static constants. So it starts out, they've already drawn a red box, and they've drawn it at row 0, 0, column 0, and they've made it box width and box height. So you can see that scales really nicely. Now we just need to figure out how to draw the rest of the checkerboard. So the really cool thing about nested for loops is that I'm going to draw a really simple checkerboard here. I'm going to do like a 3 by 3 one maybe. Wish I knew how to do straight lines in Autodesk Sketch. If any of you know how to do that, maybe shoot me an email. Might help me out. And so we've got our red ones are going to be like every other one, you know. And then that would be, this would be red, this would be red. And, oh geez, I'm already forgetting. Oh, the diagonals are all red. So you can see how good I am at this activity. There we go. Whoa. This guy's black. This guy's black. There we go. This guy is not. This guy's actually going to be red. Got some nice background music while you're watching your instructor struggle to draw a checkerboard. But anyways, just to give you an idea, this is row 0, column 0. 1, 0, 1, 1. 0, comma 1, 0, comma 2, 1, comma 2, 1, comma 1. And sorry, this is actually 2, comma 1. We're going to get up to row 2 here. 2, comma 1 and 2, comma 2. So you can see we have row 0, column 0, so the columns go this way. Often you'll see that abbreviated as cols, and rows go that way. So depending on how your brain works, you might have it flip-flopped in you might want to flip-flop it in your mind. I remember I thought columns would go, I don't know. Sometimes the rows going downwards and the columns going across makes sense to some people. Sometimes it doesn't. But this is the way it works, and this becomes increasingly important as we move on and talk about two-dimensional arrays and stuff like that. But for now, we're going to use this knowledge to draw our grid, because the number of rows will go down this way, 8 that way, and columns will go that way, 8 across. And if you remember from the activity where we drew the grid of stars, this works out nicely, because if we have a for loop that draws a set of nested for loops that does 3 iterations each, and we're drawing a square each time, we're going to get 1, 2, 3 squares. Then the rows iteration happens, and we proceed to the next row, 1, 2, 3, 1, 2, 3. And so that's the order that our checkerboard is going to get drawn in. So let's see how that is going to work with code. So we know we're going to need a nested for loop now to draw our grid of squares. So let's put this guy inside a nested for loop. I'm going to do for int I equals 0, I is less than num rows. Now, people think that, oh, well, the number of rows, we want to get 8 rows, so don't we have to go less than or equal to num rows? But remember, we're starting at 0. So less than num rows actually works perfectly. Then we're going to do for int j equals 0. Same thing, j is less than num columns, because remember, it's actually inner loop that's going to be traversing the columns and moving the square over and drawing out the whole row. The outer loop is actually just going to control the number of rows, but the inner loop is where we're actually going to draw our rectangle. So if you see this, of course, it does nothing, because we're just drawing our rectangle at row 0, column 0, 8, what is that? 3 times 3? 9 times. So that doesn't do anything. What we need to do now is we need to move our x and y coordinates to draw the square. So let's think about what needs to happen. Because box width and box height are going to change. There's no way to really hard code that in and make it work for us. So what we actually have to understand is that, let's say this is our whole window. This is 0, 0 up here. That's, of course, the x positive. This is positive y. And this is our first square that gets drawn. And this right here is box width. Well, this is 1 times box width, right? So this is, well, this would be 0 times box width because it's 0. This is 1 times box width, and then still, of course, 0 in the y-axis. This x position here would be 2 times box width, and this x position here would be 3 times box width. So because our square is going to be the same size every time, we can actually just multiply I times box width for our x position. Or actually, well, does I times box width work? Because remember, for the first iteration, I is going to be 0, because it's row 0, right? So we actually have to kind of flip-flop it. This actually has to be j times box width, and this has to be I times box height. Because notice that the box height for the first row never changes. It's always 0, the y coordinate of this box that's getting drawn. Because remember, our box is getting drawn from the upper left-hand corner. So the y-axis never changes. This is always going to be 0 for the first row, then it's going to be 1 times box width for the second row, and so on. So it's actually j, the inner for loop variable, that's going to get multiplied by box width to draw each column. So let's see what happens here. So this works really well. It actually fills our whole screen. Now, of course, we just have to figure out how to color our squares accordingly, because right now they're all just red. So let's go back to the activity directions and look at that math for determining whether the square is going to be red or black. So square should be red if the row number and column number are both even or both odd. Square should be black if one is even and one is odd. So the best way to actually determine if a number is even or odd is to mod it by 2, because all even numbers modded by 2 are 0, right? Because every even number is divisible by 2, so there's no remainder left over. So if I mod 2 is 0, or j mod 2, and j mod 2 equals 0. So if they're both even, because remember, we're making a compound Boolean expression here. If I mod 2 equals 0 and j mod 2 equals 0, we want to color it red. Or if j mod 2 equals 1, because when you mod anything by 2, the max remainder you're going to get is 1, because every other number is even and every other number is odd, right? So if j mod 2 equals 1, and I mod 2 equals 1, let's keep it going in the right order here, and j mod 2 equals 1, we're going to color it red. So if I mod 2 is 0 and j mod 2 is 0, aka they're both even, or I mod 2 is 1 and j mod 2 is 1, aka they're both odd, it's going to be red. And let's actually go ahead and set the color in this if statement before we draw. Now, the question is, do we want this to be an else if for checking if the one is odd, one is even? Well, let's think how we've got our bases covered. Colored, pun intended. So if it's going to be red, they're going to be both even or both odd. If it's black, one or the other is even or odd. So if they're not both even and they're not both odd, it has to be that one or the other is even or odd. And so this doesn't even need to be an else if, this can be an else. And they're going to get drawn at the same coordinates. The only thing that's going to change is the color. So let's go ahead and try this out. Sweet. We got our checkerboard. And it scales and it's beautiful. Now I just have to play some checkers. That's a more complex program, but you'll be able to create a game of checkers by the end of the semester. Mark my words. Now, there's one other thing we can do here. And this is something that actually my first semester teaching a student showed me, and I thought it was so cool. So this check if they're both even or both odd, it's pretty readable. Like, you get the idea. But here's something. Notice that I mod 2 is 0 and j mod 2 is 0. So I mod 2 and j mod 2 are both 0 here. I mod 2 and j mod 2 are both 1. Let me show you something that if you're like me, it's going to blow your mind. If I mod 2 equals j mod 2. Boom. It doesn't matter if they're both 0 or both 1. If they're the same, if I mod 2 and j mod 2 are the same, we know that they're both even or both odd. That blew my mind when a student showed me that. So there you have it, Activity 11. One of our quicker activity videos. I hope you're having a great week. I hope this was a fun one for you. I thought the math was pretty fun. And I'll catch you in lesson 12. Great job, everybody, and happy coding.